Live this time. That did not bode well. I tried to start the stream and internet said no. Just a second for Twitch to catch up with us. Okay, fantastic. It worked. We are good to go.
Cool.
Great. Hi. How are you doing this morning?
Good. How are you?
I'm pretty good. I'd say I'm at 80% think goodness. So, hopefully that translates into a good, easy to follow reading group. All right, so we are continuing to read this paper, Climbing Towards NLU, Natural Language Understanding, on Meaning, Form, and Understanding in the Age of Data by Emily Bender and Alexander Koller?
I don't know if I can help here.
Saarland? Be Dutch? Who knows with Dutch vowels? Certainly not me. I don't have the range.
Oh, it's definitely German.
German? That narrows it down, but I still don't know.
Okay.
So, the sort of general point of this paper is that the authors are claiming that you can understand form, so the surface structure of language, the order that words come in from just text, but you can't understand the relationship between language and the world as it exists outside of the linguistic system without something else, just to like super boil down their argument. And I believe we ended with a little story about an octopus, where the octopus test here, where there's this super intelligent octopus and it can see signals going between two islands via telegraph, and it can learn the patterns, and it can, produce new language based on those patterns. But what it can't do is understand novel things happening in the world and how language might reflect that. So if one of the people is like, help, I need assistance coming up with an idea because I'm being chased with a bear, what do I do? The octopus, who has not seen language about that topic before, won't be able to help. And I believe we got all the way up to section 5. Paula says you're amazing. Oh, thank you for joining, I guess. Do you want to kick us off?
Okay.
All right.
So section 5, more constrained thought experiments. The story of the octopus considers the problem of learning not only the full communicative system, including the relations M and C, but also the reasoning required to come up with the answers that are both coherent and also helpful in the real world. And so if you remember, the relations M and C had to do with the relationship between linguistic form and its, I think it was standing meaning, and also communicative intent. I remember that correctly.
So meaning, the M here is the relationship between the natural language expression and a communicative intent. So this is the thing that a interlocutor wants, person who is using language with another person. I'm trying to avoid saying speaking because of course this also applies to writing or signed languages. So what they mean to inform their language partner about. And then C is the relationship between language and what we might think of as like the semantic meaning, how it relates to something in the world.
Right.
Just to recheck in with those.
Okay. So here we provide 2 more constrained thought experiments to focus more narrowly on the problem of learning the meaning relation, both from natural languages and programming languages. So this should be fun because programming languages are meant to communicate both to the computer and to the other programmers. Because programming languages are designed to be unambiguous and relatively insensitive to execution context, the distinction between standing and speaker meaning is less important than for natural languages. A Java program E, when compiled and executed on the Java virtual machine, can be interpreted as a function I, which maps program inputs to program outputs. We take the meaning relation, J is a subset of E cross I of Java to contain all such pairs, E, comma I. So I guess I'll keep going.
Oh yeah, go ahead.
So Java. Imagine that we were to train a language model on all of the well-formed Java code published on GitHub. Please don't. The input is only the code. It is not paired with bytecode, nor a compiler, nor inputs and outputs for any specific program. We can use any type of language model we like and train it for as long as we like. We then ask the model to execute a sample program and expect correct program output.
That's optimistic, I would say.
Yes.
AI says, solution says, excellent initiative discussing papers. How can we participate? Predominantly in the chat. So right now the video discussees are all Rasa folks. Adam Lopez is our head of research.
Research manager.
Research manager. Sorry, I'm not the best at remembering titles.
I'm the old researcher.
Senior
citizen researcher.
It's, I don't know, I think a lot of people who are very new to research and scholarship don't necessarily appreciate at first the value of having a real depth of understanding and like time depth of a field and sort of like what's come before and the way that, you know, research is built on each other. It turns out very important, and much of doing a PhD is learning and understanding that time depth and the way that things have evolved. I could take AI solutions say, do you share the paper title in advance? Usually at least the day before. All right. English.
Should we talk about the Java? I mean, this is a really nice example, right? Because you know, the nice thing about like a Java program, ideally, it's not, at least it hasn't always been true. Because I sort of remember the early days when there were actually some issues with the specification. But ideally, you know, if you're given a Java program, it has one meaning. You know, if you think about like how it gets compiled down to bytecode, or even I guess the difference is when you can compile it to bytecode, but the meaning, if you just think of the meaning in terms of like the input and output pairs it produces between, like, given a particular input, it should always produce this output. You can think of that as being sort of the set of all those pairs as being the meaning of the Java program. And there is just no way that you are going to learn that correspondence just from the form of the Java program. It's completely nonsensical.
Yeah, I would agree. I feel like I had something. Completely forgotten it, and that's okay. If it's important, it'll come back to me. Solutions, please share them with us in advance. We can understand this discussion better if you do so. William Cram said, agreed. Thanks for bringing that up. Yeah, I think I can commit to sharing the paper on the Monday before the Thursday we read it. So, reminder. Sorry, if I don't write it down, it's not going to happen. Okay. Yeah, so computer languages have this nice property where they are unambiguous. Human language is deeply ambiguous. So for, you know, one surface form in a computer language, you have a single syntax tree that can be derived. Would derived be the right word there? Constructed from it? Mapped to it?
I think that's right. You know, I mean, there's like a bunch of other things. There's abstract syntax trees and bytecode and other things, and you can kind of play with some of these things. But I think the key thing, like if I think of the meanings being just like the sort of the universe of like input-output pairs, ideally there's some meaning that you intend for that program, and that bit is should be constant, I guess, fixed.
Which is not the case in English or any other human language. Um, I gotta come up for. Gotta. What's a good example of a ambiguous sentence syntactically? I'm only coming up with morphologically ambiguous stuff.
Prepositional phrase attachment is always good for this. I saw the man with
With
the
the
telescope.
telescope.
Yeah.
Yeah. So the example is like, I saw the monkey with the telescope. Do you have the telescope, or does the monkey have the telescope? They are both reasonable interpretations of that sentence, which I imagine we're about to talk about. So let's read the next section. I can take this one. As a second example, imagine training a language model, again, of any type. Fun fact, you can create a language model without using transformers. It's true.
We used to do it with n-grams.
That's
How barbaric.
when I was applying for faculty jobs, that was my sample lecture. It was about n-grams. Anyway, English text, again with no associated independent indications of speaker intent, so you just have the input text. The system is also given access to a very large collection of unlabeled photos, but without any connection between the text and the photos. For the text data, the training task is purely one of predicting form. For the image data, the training task could be anything, so long as it only involves the images. At test time, we present the model with inputs consisting of an utterance and a photograph, like how many dogs in the picture are jumping, or Kim saw this picture and said, "What a cute dog. What is cute?" And the photos in figure 1, sorry, I thought this was the caption of figure 1, where the appropriate answers are a number or region of the photo, respectively. So here is a photo with 2 kitties and a doggy, and we're talking about the dog. And here's a photo of 4 dogs, and 3 of the 4 are jumping. So that would be the correct answer to those questions. I can take the next section too. In both cases, the tests are ridiculous. It seems patently unfair to ask the model to perform them given what it was trained on. But that is precisely the point we're trying to make. A system that has learned the meaning, semantics, of a programming language knows how to execute code in that language. And a system that has learned the meaning of a human language can do things like answer questions posed in that language about things in this world, in this case, in pictures. So just to go over the present the model. Okay, so there are 2 models, or is it 1 model with 2 parts? Language model and the unlabeled photos. For the text data, it's predicting form. So it's a language model predicting what word comes next. Excuse me, what word comes next. The image data, the training task could be anything. You only get the images. At the test time, we present the model with inputs. Okay, so 2 models, 1 trained just on images, 1 trained just on language, and then the test for if it's a good model is you have a picture and a sentence, and you ask for information about the picture using text. But previously, the model has had no access to the relationship between text and image, so there's no way that it could do the task. So I guess sort of a related example is a lot of like text imaging generative stuff, or text labeling generative stuff. If you ask how many X are there, even if there aren't X in the picture, you'll often get a number back. So the example I've seen a lot of people use is like how many giraffes. So I'd input this picture to like a text captioner and be like, how many giraffes are in this photo? And it'd be like, there's 4. There's no giraffes in the photo. But because the language model component knows that if you ask how many, the answer is a number, you tend to get that type of error. It's also just like a fun test to do with language models in general, to see sort of like how long the attention is. It breaks AI dungeon. Sorry, I am completely off topic. I warned you, I'm 80%.
No one's 100% these days.
Very true.
Good.
Okay, second paragraph. In other words, what's interesting here is not that the tasks are impossible, but rather what makes them impossible, what's missing from the training data. The form of Java programs to a system that has not observed the inputs and outputs of these programs does not include information on how to execute them. Similarly, the form of English sentences to a system that has not had a chance to acquire the meaning relation C of English, and in the absence of any signal of communicative intent, does not include any information about what language external entities the speaker might be referring to. Accordingly, a system trained only on the form of Java or English has no way to learn their respective meaning relations. So, like an example for Java might be a language model might learn that I need to always have, a semicolon before a carriage return, but it's not going to learn that before I use this variable, I need to define it. That sort of thing. Do you want to take the next section?
The next section is on human language acquisition. One common reason for believing language models might be learning meaning is the claim that human children can acquire language just by listening to it. This is not supported by scholarly work on language acquisition. Rather, we find that human language learning is not only grounded in the physical world around us, but also in interaction with other people in that world. Kids won't pick up a language from passive exposure such as TV or radio. Snow et al. In 1976 note in passing that Dutch-speaking kids who watch German TV shows by choice nonetheless don't learn German. Koller, 2007, shows experimentally that English-learning infants can learn Mandarin phonemic distinctions from brief interactions with a Mandarin-speaking experimenter, but not from exposure to Mandarin TV or radio.
That study was from the iLabs. Peckle did a lot of collaboration with my advisor, and I think that's a study she did at the University of Washington. That's where I did my degree. Again, tangent, sorry. I'm gonna pull it back in. Do you want to take the next paragraph?
Sure. Baldwin and others argue that what is critical for language learning is not just interaction, actually joint attention, i.e., situations where the child and a caregiver are both attending to the same thing and both aware of this fact. This theoretical perspective is substantiated with experimental results showing that toddlers observed at 15 and 21 months, whose caregivers follow into their attention and provide labels for the object of a joint attention, more, have larger vocabularies.
You got garden path.
That toddlers 18 to 20 months old don't pick up labels uttered by someone behind a screen, but do pick up labels uttered by someone performing joint attention with them. And that around 10 to 11 months of age, babies pay attention to whether a person's eyes are open or not in terms of whether to follow their gaze. And the degree to which infants, in fact, follow gaze at 10 to 11 months while vocalizing themselves predicts vocabulary comprehensions 7 to 8 months later. Wow, those are long sentences. But I think the key point here is there's a ton of experimental evidence that says it's the interaction that matters in language learning, not just sort of passive absorption.
Yes, which is also, just to answer a question from the chat, who is here on the bottom left? This is Adam Lopez, who is a research manager at Rasa and was previously at Edinburgh. He's a well-known researcher in the NLP community, and I'm delighted to have him, both at Rasa and also today in the paper reading group. And just Thanks. A little background that they didn't bring up but might be relevant here. So Chomsky, who's a very well-known linguist and computer scientist, back when linguistics and computer science were kind of the same thing, which was at one point in history the case, is, I feel like poverty the stimulus is mostly his thing. So this claim that humans have an innate ability and sort of like mental structures to acquire syntax because we can do it with only access to language data and nothing else. And this idea has sort of like, a lot of people have thought about it and discussed it, and this section here is providing research that that's not actually the case. And it's important that you, to acquire language, which is how you pick up language without having a language previously, you need social interaction, you need other people, you need this sort of like social milieu I think embodiment researchers would argue that you need a body and that there's important biological processes that are at play as well. But the payoff here is that humans don't learn just from raw language input. If they did, I would speak Chinese. And I just do not. So I'll just read the summary paragraph. In summary, the process of acquiring a linguistic system, like human communication generally, relies on joint attention and intersubjectivity, the ability to be aware of what another human is attending to and guess what they are intending to communicate. Human children do not learn meaning from form alone, and so we should not expect machines to do so either. Which is, in the case, Adam Optimizer.
That's my favorite.
You didn't come up with that, right? No. I feel like I would have figured that out at some point.
My favorite thing, like for the last few years, I have just read all these NLP papers, and and I always run across this sentence: "We optimize our models with Adam." And I'm like, yes, thank you. I optimize all the models.
Oh. Yeah. Also, I will say this is one of the better sections on language acquisition that I've seen in an NLP paper. I love y'all. But sometimes when you're talking about a field that you're not super familiar with, there's, I think, a little bit of a disciplinary bias towards not reading as deeply as would be helpful in that other field that you have not spent a lot of time in.
I mean, I've certainly seen, without naming any names, some papers in NLP that refer to language acquisition literature to justify some heuristic machine learning technique, and sort of go a little too far. I mean, it's biologically inspired is totally fine. Like, people draw inspiration from all kinds of sources, but then sort of trying to make any like further cognitive claims based on that is really, really sketchy.
Yeah, cognitive modeling is like a whole other thing. It's if it's something you're interested in, I recommend learning more about it, but claiming that you have a cognitive model is a very, very, very strong claim. Distributional semantics. We promised this. So distributional semantics is like word vectors, that sort of thing. And I imagine we'll talk about this. Distributional semanticists have long been aware that grounding distributional representations in the real world is challenging. So if you're using how often words occur together as a proxy of the way that things are in the world, you're going to run into problems. The lexical similarity relations learned by distributional models trained on text don't in themselves connect any of those words to the world. Citations. And the distribution of words may not match the distribution of things in the world. Consider four-legged dogs. So this is like another example I've seen used here is black swan. So people are much more likely to use adjectives to describe something that is unusual. Most dogs have 4 legs, so it is rare to see someone say four-legged dog because you would assume by saying dog that it has 4 legs. Or black swan, when I say swan, I think most people assume that they're going to be white. But if you are relying on a language model, most swans are going to be black because that's the color that's most used when discussing swans, because that's the unusual one, right? That's the one you bring up.
Yeah, I think I've seen this referred to as, well, various flavors of this referred to as reporting bias. Like, we're not just sort of walking around giving a completely uniform and objective description of everything that we see that's going on in the world. We're talking about things that are sort of interesting in our social context. And so that means that, you know, the language that we speak in like a giant corpus of the language we speak isn't at all sort of a just like perfectly clear reflection of everything that's going on in the world, like as if you're just looking at it through a window.
Yeah. I think this is true of, you know, lots of sort of computational representations of things, like video games, for example. There's a lot of video games about like killing people. That's not an experience most people have, and it's not like a super common part of being in the world. There are far fewer video games about like eating food or Raising children, which are very common human experiences. Or gardening, which is my huge pet peeve. I want more gardening video games.
Yes, that would be awesome.
Right? There are some. We can talk after about gardening video games. One approach. Oh, wait, this was your section. Sorry, go ahead.
Okay. One approach to providing grounding is to train distributional models on corpora augmented with perceptual data, such as photos or other modalities. Another is to look to interaction data, e.g., a dialogue corpus with success annotations, including low-level success signals such as emotional stress or eye gaze, which contains a signal about the felicitous use of forms. The idea that as a learner gets access to more and more information in addition to the text itself, it can learn more and more facets of meaning is worked out in detail by Disk et al. We agree that this is an exciting avenue for of research. And I think I would agree with that as well. And also that this is like a very, very way early days, this area. There's a lot of interest in it, and it's very interesting. It requires, usually expertise in NLP and like whatever it is that you're combining language with. And there's cool stuff being done, but it's hardly going to solve meaning in the next year or anything.
And felicitous here, does this mean grammatical or does this mean reasonable in the social context? So by grammatical, I mean a sentence that a native speaker of a language would produce and also accept perceptibly as a valid sentence. I'd have to read the paper, I think.
Yeah.
But sometimes when people say felicity in NLP papers, that's what they mean. You want to finish it out?
From this literature, we see that the slogan, meaning is use, often attributed to Wittgenstein, refers not to use as distribution in the text corpus, but rather that language is used in the real world to convey communicative intents to real people. Speakers distill their past experience of language use into what we call meaning here, and produce new attempts at using language based on this. This attempt is successful if the listener correctly deduces the speaker's communicative intent. Thus, standing meanings evolve over time as speakers can different experiences. I think that's a
typo. Yeah.
And a reflection of such change can be observed in their changing textual distribution.
Interesting. So I'm getting from this that the authors think that a lot of the distributional semantic claims are a little bit overstated because the distribution in case is distribution in a text corpus and not distribution in use in context.
Yeah. In an environment.
Which I think most people would say that distributional semantics is, as at best, sort of a lossy representation that has some use in systems. So there's nothing wrong with using it, but it's not, you're not going to get the full range of meaning. Interesting. It's been a while since I've read Wittgenstein, and I am not going to go back and reread it. Actually, I think I might have gotten rid of my hard copies. All I have to say about it. Next section, on climbing the right hills. What about systems which are trained on a task that is not language modeling, say semantic parsing or reading comprehension tests? Semantic parsing is I've definitely read about this task. I don't know that I remember what it is well enough to explain it.
I'll see if I can sort of give a stab at it. I mean, there's a lot of different flavors of this. I tend to, like, in sort of practical terms, I guess I would think of it as like practical applications of this would be something like you want to take natural language as input, and you want to produce some kind of something that can be executed by a computer. So like an API call. So if you talk to Siri, say, and you ask it to look up something on Google, it basically has to listen to it, and then it has to execute a function. And that function is, open up Google and input a search term. There's, of course, lots more to semantic parsing this, because there's a whole literature on trying to parse to sort of various flavors of, I guess, what I would call sort of Montegovian semantic forms, or the Neo-Davidsonian semantic forms, and an infinite number of flavors of these, which are all very interesting, and all sort of slightly broken in certain ways, and that they can't. It's really, really hard to design a logical form that captures all of the meaning. It's there's lots of interest in capturing the standing meaning, but then you also even capturing the communicative intent in those is super difficult. I don't think I know enough about sort of data sets where there's a lot of interest in capturing communicative intent, except of course dialogue systems, where it's often sort of in a fairly coarse form as like an intent or something.
That's helpful, thank you. Or reading comprehension tests, which are, can you answer the question good? Did you understand what was going on? And that use word embeddings from BERT or some other large language model as a component. Numerous papers over the past couple of years have shown that using such pre-trained embeddings can boost accuracy of the downstream system drastically, even for tasks that are clearly related to meaning, which I think is reasonable. Having a good model of form and sort of like fluent sounding text is super helpful. Our arguments do not apply to such scenarios. Reading comprehension datasets include information which goes beyond just form, in that they specify semantic relationships between pieces of texts, and thus a sufficiently sophisticated neural net model might learn some aspects of meaning when trained on such datasets. It is also conceivable that whatever information a pre-trained LM captures, language model, might help the downstream task in learning meaning without being meaning itself. So they're saying here that they're talking about language models that are only trained on surface form and don't learn, relationships between things in the world. And in this case, they're suggesting also that multiple texts that have relationships between each. It looks like I'm still streaming. There we go. Okay.
Okay.
Internet disconnected.
Oh, okay.
All right, and we'll reconnect soon. Brief network outage. ERB. All right, and there we go. Fantastic. Okay. I feel like my network is even more unstable than usual this morning. Anyway, blah, 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 blah. What were we talking about? Recent research suggests that it is wise to interpret such findings with caution. As noted in both McCoy et al. 2019 and Niven and Cao 2019, as noted in section 2, both these papers found that BERT picked up idiosyncratic patterns in the data for their task and not meaning. So I believe the Niven and Cao paper was like, one of the tasks was can BERT negate things or identify things that are negations of other things, and the thing that BERT can do is find if the word no is in the text. Idiosyncratic patterns and not meaning. Beyond such diagnostic research on why large pre-trained language model boost such tasks so much, we think there is a more fundamental question to be asked here. Are we climbing the right hill? The assumption there being that there's many questions that you could ask or research problems that you could look at. Which one should we be doing? You want to take the next section? Unless you have something to add.
No, I think so. Are we at 8.1? Okay. there are two different perspectives from which one can look at the progress of a field. Under a bottom-up perspective, the efforts of a scientific community are driven by identifying specific research challenges. A scientific result counts as success if it solves such a specific challenge, at least partially. As long as such successes are frequent and satisfying, there is a general atmosphere of sustained progress. By contrast, under a top-down perspective, the focus is on the remote end goal of offering a complete unified theory for the entire field. This view invites anxiety about the fact that we have not yet fully explained all phenomena and raises the question of whether all our bottom-up progress leads us in the right direction. There is no doubt that NLP is currently in the process of rapid hill climbing. Every year, states of the art across many NLP tasks are being improved significantly, often through use of better pre-trained language models. And tasks that seemed impossible not long ago are already old news. Thus, everything is going great when we take the bottom-up view. But from a top-down perspective, the question is whether the hill we are climbing so rapidly is the right hill. How do we know that incremental progress on today's task will take us to our end goal, whether that is general linguistic intelligence, or a system that passes the Turing test, or a system that captures the meaning of English, Arapaho, Thai, or Hausa to a linguist's satisfaction? Do you want to stop and think on this for a second?
Yeah, I think that is a really good question. What is the point of NLP? What are we doing? How will we know when we're done? And I think for me, I'll say first of all, I'm not worried about the singularity. It's like AGI is not, I think, a likely or useful metric for analyzing things. I think I'm not really doing science anymore, right? I'm more of a developer, engineer, building systems. And I think what would be sort of like the end goal of NLP for me, from where I'm currently sitting, is do we have the tools that anyone can build a language-based system in their language, or the language that's most important to them? So this cannot be just English, and have it accomplish the tasks that they need it to accomplish. So can, somebody who's cooking design themselves a system that will allow them to say, hey, I want to make this tomorrow, and then they get their shopping list back, and then they get a reminder of what's on their shopping list when they get to the store, and they have control over that process, and that it can be done in whatever language they're using, which I think is not most people's idea of what the end of NLP will be. I don't know. What are your thoughts?
I have a lot of thoughts about top down versus bottom up. I mean, oh boy. There's probably more to be said about this than I could say here, but I actually think a lot of the sort of questions that, let's say, you see famous people talking about with respect to artificial general intelligence are fairly nonsensical. Like, they seem very ill-posed to me. But I also don't really think the goal of NLP is to solve intelligence or general linguistic intelligence. I mean, I think NLP tools are useful in, for instance, cognitive science, where people are trying to answer those questions, but they're just tools. I mean, basically all of what is currently called AI is just it's just automation. That's it. And you can only automate things that you understand. So yeah, so I do really worry about sort of automating things you don't understand, which in machine learning usually means you're sort of mining spurious correlations, or perhaps unsavory correlations in your data without realizing it. That's not so good. And so I really kind of feel like a lot of the discussions around artificial general intelligence or whatever are they're almost a distraction from like what's actually important. Actually, no, I'll just come out and say they are a distraction from that. And
I think it's not the most pressing concern, right? The most pressing concern is, are the systems that are being built right now genuinely helping people? Are they genuinely helping end users? Are they genuinely bettering the life of stakeholders? And I think in some cases the answer is yes, and I think in some cases the answer is clearly no. And there are people building systems that are creating and perpetuating harm and are not taking responsibility for that and are instead trying to, I don't know, maybe I'm being a little bit cynical. I think there is a sort of it's a little self-serving for people who are in a position where they have the ability to genuinely do good and fix harms that are being done right now, to talk about sort of like hypothetical things that might happen in the future in a way that sort of absolves them of responsibility or redirects attention towards things that they don't have a duty of care towards. I don't know. I think we both have a lot of thoughts about this.
I guess maybe, to bring it back to the paper just a little bit. I guess to my mind, the thing is, there is a top-down agenda in NLP. I mean, there is lots of bottom-up reasons, but there is a top-down agenda in NLP, and it is not to solve general linguistic intelligence. And the way to figure out what that agenda is to see who's paying for it. And I'll leave it at that. But most of the organizations paying for it are not aiming. And again, like I think as you say, like there are lots of examples of organizations who want to do good things and benefit people, and there are examples of organizations that don't do
that. Anyway, it is instructive to look at the past to appreciate this question. Computational linguistics has gone through many fashion cycles over the course of its history. Grammar and knowledge-based methods gave way to statistical methods, and today more research incorporates neural methods. Researchers of each generation felt that they were solving relevant problems and making constant progress from a bottom-up perspective. However, eventually serious shortcomings of each paradigm emerged, which could not be tackled satisfactorily with the methods of the day, and these methods were seen as obsolete. This negative judgment, we were climbing a hill but not the right hill, can only be made from a top-down perspective. We have discussed the question of what is required to learn meaning in an attempt to bring the top-down perspective into clearer focus.
So onto hill climbing diagnostics. We can only definitively tell if we've been climbing the right hill in hindsight, but we propose some best practices for less error-prone mountaineering. First, above all, cultivate humility towards language and ask top-down questions. Neural methods are not the first bottom-up success in NLP. They will probably not be the last. Second, be aware of limitations of tasks. Artificial tasks like, I don't know how to pronounce this, baby, can help get a research field off the ground, but there is no reason to assume that the distribution of language in the test data remotely resembles the distribution of real natural language. Thus, evaluation results on such tasks must be interpreted very carefully. Similar points can be made about crowdsourced NLI datasets such as Squad or SNLI, which do not represent questions that any particular person really wanted to ask about a text, but the somewhat unnatural communicative situation of crowdsourcing work. And so these are natural language inference, I think is there's a whole lot of data sets of this type. These are two like very popular ones. And as is pointed out, they were not generated in which is sometimes described as ecologically valid setting. That is, they were not generated by people who were actually asking questions. They were generated by people sort of solving some other task. And there's some interesting sort of papers sort of analyzing what's in these data sets, and some of it's troubling. In any case, if a system does better on such a task than the inter-annotator agreement, the task probably has statistical artifacts that do not represent meaning. In the vision community, Barbu et al. Offer a novel data set which explicitly tries to achieve a more realistic distribution of task data. It would be interesting to explore similar ideas for language.
So just to, I don't know how common inter-annotator agreement is as a term that people would come across. So basically, if you have, a sort of a difficult task you want a human to do, the way that you'll sort of see how doable it is that you'll have a bunch of people do the exact same task and then see how often they agree. So that's inter-annotator agreement. And what they're saying here is that if your system does better than a collective group of humans on a task on some metric, it's probably not doing the same task, right? So like if I have a color prettiness task where I ask people to rank how pretty a bunch of colors are, and then I have another system that ranks how pretty colors are, if there is the system comes to a more consistent set of answers than a large group of people, probably it's not using whatever same quality judgments human would in that situation. Maybe it wasn't the best example, but take the rest of the section.
Third, value and support the work of carefully creating new tasks. For example, the DROP reading comprehension benchmark seeks to create more stringent tests of understanding by creating questions that require the system to integrate information from different parts of a paragraph via simple arithmetic or similar operations. Sounds interesting. I actually am not familiar with this data set. Fourth, evaluate models of meaning across tasks. Standing meaning is task independent, so a system that captures meaning should do well on multiple tasks. Efforts like superglue seem like a good step in this direction. Finally, perform thorough analysis of both errors and successes. McCoy et al. And Niven and Cao have shown systems that find success with large pre-trained language models do not necessarily do so because the language models have learned meaning.
Quote unquote.
Analyses which start from an attitude of healthy skepticism, viewing things as too good to be true, and probing tasks which try to identify what the model actually learned can be good ways to find out whether the system performs well for the right reasons.
I think that's also just a good stance for engineers to have in general.
Yes.
It's just like, kind of about this.
You
sure?
There's a bit of advice. I think it's on Kevin Gimpel's webpage, where one of the it's advice for PhD students, and I've sent it to my PhD students on occasions. And one of the bits is, you probably have a bug, and then after you fix 10 bugs, you still probably have a bug. So it's always good to sort of look at these things and see. And arguably you could say, like, some of these things, like these data set artifacts that some of these models pick up on, from the perspective of the task you're trying to solve, they're bugs. I mean, these are crazy over-parameterized models, and they can pick up on basically any correlation that exists in the data, which may or may not be the correlation that you actually wanted to pick up on. And it's really, really hard to get down to what it's actually doing.
Yeah. Question from Fun Researcher: is cognitive modeling similar to choice modeling? Familiar with choice modeling? Really quick. Attempts to model the decision process of an individual or segment via revealed preferences or stated preferences made in particular context or contexts. That sounds more like behavioral psychology to me. Cognitive modeling is, I say it's a field of psychology, but also like neuroscience, where you're trying to use a computer to model cognition, like model what's happening in oh, I'm going to use the wrong terms now because this is not my field. Not necessarily model the biological processes happening in the brain necessarily, at sort of like a nerve level, but to sort of approximate the emergent processes of cognition. Don't at me, cognitive modelers. Or do, please, and I'll share a better decision. But choice modeling seems simpler based on my quick perusal of the first paragraph of the Wikipedia page. Or at least a more narrowly defined question. All right. Oh, and just a quick thing I wanted to say about... support the work of carefully creating new tasks. It is rough to get a task paper published.
It is.
So if you're reviewing, maybe like really think about the potential. I know the latest was it the MNLP review guidelines had really good discussion about like, hey, don't just look at the benchmarks. Think about like, how does this fit into the larger research environment, and how does this like benefit the field as a whole? So just be nice to people who make tasks. It's so much work. It's way more work than building a system.
Amount of work. Creating tasks and data sets is very, very hard.
Yeah. One of the things that one of the questions I get a lot at Kaggle is people would be like, here's my research question, what's my data set? And I'm like, if it doesn't exist, how is my data set is your research question? Like that is a full PhD.
Yeah.
All right, some possible counter arguments. You read Rasa, yeah. In discussing the main thesis of this paper with various colleagues over the past 18 months, we reserved recurring counter arguments. In this section, we address those counter arguments plus a few more that might arise. But meaning doesn't mean what you say it means. Defining meaning is notoriously hard. For the purposes of this paper, we chose a working definition which is as general as we could make it, capturing the crucial point that meaning is based on the link between linguistic form and something that is not language. Which I think is, I don't think even the most like wizened of semanticists would be super upset with that as a general description. Meaning cannot simply be the relation between form and some kind of deep syntax, e.g. semantic dependency graphs. Like syntax, sub-representations could perhaps be learned from form alone. Equating these with meaning ignores a core function of language, which is to convey communicative intents. Which I think is true. Like, even if you can learn from text that, like, elephants have trunks and that they live in Africa and India and that they have tusks, and you learn various information about elephants, that's necessarily going to help you building a system to identify poachers, right? Maybe to identify classified ads that might have been put up by poachers. You shouldn't use automated systems to be like, this person's a criminal. That's a bad task. Don't do that.
No, don't do that.
But, you know, perhaps to generate leads to, you know, this person might be selling smuggled goods or something. That might be a less bad task. I don't know why I went with elephants. But meaning could be learned from ... As we discussed in section 7, if a form is augmented with grounding data of some kind, then meaning can conceivably be learned to the extent that communicative intent is represented in the data. In addition, certain tasks are designed in a way that specific forms are declared as representing certain semantic relations of interest. Examples of this include NLI, natural language inference, datasets, which pair input-output tuples of linguistic forms with an explicit semantic relationship, e.g. text plus hypothesis plus entailed. And there's what's the task? Everyone, it's part of Glue. People have used it a lot. And I forget the task, but you can look it up. Similarly, control codes, or tokens like TLDR, have been used to prompt large language models to perform summarization and other tasks. And this is basically what GPT-3 is doing. So you give it like a little snippet, and then it continues to generate things. Here, forms are explicitly declared at test time to represent certain semantic relationships, which together with the distributional similarity between e.g. TLDR, this means too long didn't read, so it's an abbreviation to say, this previous text was very long, here's a summary of it. And other phrases such as in summary may be enough to bootstrap a successful neural summarizer. Depending on one's perspective, one may argue that such a system has learned to reliably find instances of the relation without understanding the text, or that explicitly declaring cues like entailed or TLDR as representing certain semantic relations provides a training signal that goes beyond pure form. Analogously, it has been pointed out to us that the sum of all Java code on GitHub, see section 5, contains unit tests, which specify input-output pairs for Java code. Thus, a learner could have access to a weak form of interaction data from which the meaning of Java could conceivably be learned. This is true, but requires a learner which has been equipped by its human developer with the ability to identify and interpret unit tests. Thus, this learner thus has access to partial grounding in addition to the form. Yeah, I don't have anything else to add here. Do you want to
Sure.
Take the next section?
So this is another counter argument. But there is so much form out there. Surely that is enough. Oh my god. The terrifying argument. Just imagine training your system on all of the text on the internet, which is all just perfectly true and has no agenda or anything else in it. Oh my god. Okay. We have argued for the general principle that learning meaning requires more than form. How much form can be observed is not relevant to our point. The octopus can observe A and B for as long as he wants, and the quantity of training data in section 5 is not limited. But given lots of form, could O perhaps learn to keep producing seemingly meaningful responses to A's utterances without learning meaning? The problem is that people constantly generate new communicative intents to talk about their constantly evolving inner and outer worlds. Thus, O would need to memorize infinitely many stimulus-response pairs. Such an approach may be an avenue towards high scores in evaluations where perfection is not expected in any way, but it is probably not an avenue towards human analogous NLU.
Yeah. And I would also say, just on a more practical level, there's a lot of English. There's not as much like Hungarian or Swahili or I'm trying to think of an Aboriginal language. Ugh. I can't think of any of the native languages of Australia off the top of my head. Sorry, Jack. Do you want to take the next session?
Yeah.
Unless you have something else.
So another objection, but aren't neural representations meaning too? The internal representations of a neural network have been found to capture certain aspects of meaning, such as semantic similarity. As we argued in section 4, semantic similarity is only a weak reflection of actual meaning. Neural representations neither qualify as standing meanings, lacking interpretations, nor as communicative intents, being insufficient to, for example, correctly build a coconut catapult. An interesting recent development is the emergence of models for unsupervised machine translation trained only with a language modeling objective on monolingual corpora for the two languages. If such models were to reach the accuracy of supervised translation models, this would seem to contradict our conclusion that meaning cannot be learned from form. A perhaps surprising consequence of our argument would then be that accurate machine translation does not actually require a system to understand the meaning of the source or target language sentence. And so I think as a good example of that is this exercise I mentioned last.
Oh, we may have lost connection.
Oh,
wait, okay, we're back. The exercise you mentioned last week.
Yeah. So in this exercise, students, given a handful of examples, can translate Centauri to Arcturian, two made-up languages, without having any idea what those things mean. I mean, I think there's probably a lot more to say about this, and I feel like I've had discussions with people about this at various points. About whether you need, obviously in the machine translation community.
You're cutting out a little bit. I don't know if you can still hear me.
Okay.
Oh, you said there's a lot more to say about this, and then
yeah, there's a lot more to, like, the machine translation community has a long history of sort of let's say discussion and disagreement over whether you even need any kind of meaning in order to perform translation. And I mean, for certain, I don't. There. I think in some of the recent Google papers, they refer to sort of their the sort of the encoded representations as an interlingua, and it's a controversial way of thinking about it, I think.
I don't know that I come down on one side or the other particularly strongly. I can take the next section. But BERT improves performance on meaning-related tasks, so it must have learned something about meaning. That's a strong claim. So if you're just in general, the stronger your claim is, the more evidence you need for it. It has probably learned something about meaning in the same sense that syntax captures something about meaning and semantic similarity captures something about meaning. A potentially useful but incomplete reflection of the actual meaning. McCloy et al. 2019 and Niven and Cow 2019 provide cautionary tales about overestimating what that something is purely based on evaluation results on existing tasks. What exactly BERT and its relatives learn about meaning is a very interesting question, and we look forward to the further findings from the field of BERTology. Yeah, I think that this is still an open question. I think we know more about it for BERT than we do for GPT-3 for sure. I take the conclusion. In this paper, we've argued that in contrast to some current hype, meaning cannot be learned from form alone. This means that even large language models such as BERT do not learn meaning. They learn some reflection of meaning into the linguistic form, which is very useful in applications. Which I think is true. Large language models are, depending on your system, a very useful component to include. I would not replace your system with them. We have offered some thoughts on how to maintain a healthy, but not exaggerated, optimism with respect to research that builds upon these language models. In particular, this paper can be seen as a call for precise language use when talking about the success of current models, and for humility in dealing with natural language. With this, we hope to encourage a top-down perspective on our field, which we think will help us select the right hill to climb towards human-analogous natural language understanding.
Yes, please.
I think that's a very healthy stance to have. I mean, particularly when you think about the history of natural language processing as a field, there are like a couple of times where a new approach came out, people were super excited about it. Like, it was all anybody talked about. It was like the hot research topic. And then like a couple years later, they were like, oh, and here's what it can't do. Here's, ooh, excuse me, get my little dust door. Here are the limitations of this approach. Here's where it doesn't work. And then people are like, oh, NLP is not a useful field anymore. And then the next hot thing came in. I would say it's less, the cycle is less strong than it is in sort of machine learning research in general. Like, NLP has never had like the complete AI winter experience, but you know, there's this still sort of like, things are exciting, and then you're like, oh, it's not good at everything. It's exciting. So I think that this paper offers really helpful historical perspective.
Yeah. I think I would agree with that. I mean, I think it's sort of, I think we are in a strange place in the field just because I mean, when you look at the output, so it's maybe interesting to think about things like GPT-3, which, you know, the output is really sort of remarkably fluent and coherent over much longer. I mean, maybe my perspective on this is just having been around long enough that it wasn't that long ago that we were still using n-gram models, and so I think when I started in the field, like you would build like a machine translation or recognizer with like a trigram model. That was kind of typically what your researchers was doing, and then like there was this amazing moment when the first statistical Google Translate, they used like a 6-gram model internally, and that was there was some. I was actually at this workshop where the Franz Ock, who kind of wrote the first statistical Google Translate and has sort of a long history in that field, sort of had kind of gone into hiding, where he went into Google in like 2003, and he had been doing all this great research, and no one heard from him for a couple of years, and he comes out, gave this invited talk at this workshop, and I remember him showing this graph where they trained the first, basically this was the first language model trained on the whole web, and he just showed how this like improved the performance of the system. It's like people in the audience gasped because all the academics were watching all of their research agendas blow up in their face. It was really fast. It was amazing. But no one at that point, like, you know, you could build these humongous n-gram language models and then use them. You know, a thing that you would do back then is you would train on, let's say, George W. Bush speeches, and it would generate sort of nonsense that sounded like George W. Bush, which is funny because it's George W. Bush and he often talked nonsense to begin with. But no one thought that that was, you know, everyone would look at this, oh, it's just a statistical parlor trick. I mean, it's not, no one thought in it, I hope no one, I don't remember anyone saying an n-gram model knew anything about language. I mean, they made fairly strong claims about like how far we would get with it. In retrospect, those were probably silly, but still, like it's really interesting when you look at these things today. It's like much harder to GPT-3 really is, it's the same parlor trick. It's just with way better special effects and a much bigger budget, but that's it. And you know, I sort of wonder if we're in some sort of, I don't know, like an uncanny valley with NLP. I don't know what that would mean, but it's sort of this, because it also has like really crazy failure modes where it just does ridiculous things. And so for sure, the technology has gotten quite a bit further, but it's pretty clear these problems are all still there.
Yeah. And it's interesting to me that, I don't know, I feel like there's a little bit of a person with a hammer approach right now, where we are, as a field, focusing on problems that do tend to work pretty well with this sort of like large transformer based model. But I think there's also a really large swath of problems where it's just not a good approach, for, you know, any number of reasons. And a big one is, I know I keep bringing this up, but it's a big problem, and that's data availability. Like if you require a terabyte of training data in your language of choice in order to build a model, that's going to work for English, maybe Mandarin at some point. And that's, I mean, in big part because, you know, most languages of China share the same writing system, and you have a lot of text data that's been that you could use to sort of like bulk up that corpus. And like, what other languages do you have that with? The majority of people on Earth don't speak English. Like, whose problem are we solving? I mean, the answer is tech workers' problems, which as it turns out, we're like a fairly non-representative sample of the human experience, and I'm becoming increasingly frustrated with that sort of overall bias. I don't know, I'm a little bit off topic now. Like we're not focused as much on language models, but language models is just sort of like an approach. Are even if they did do what a lot of the boosters and hype say that they do, which I think there's a lot of very strong claims that have been made that evidence has not been provided for.
Yes.
It's still only a partial solution for only some people. Oh, Olga. Sorry, I just looked at the the acknowledgements. I know some of these people.
I know some of these people too.
Yeah. Decent.
Many friends here.
NLP is not that large of a field.
Yeah. Super. Well, this was fun. I mean, I think this is a good paper to read. Like, this is a really important argument.
Yeah. I think it's a good discussion to have. And I think when the sort of like crush on GPT-3 wears off, and we're like, oh, I actually don't want to like move in with this model for all of I don't know. I don't know why that's the metaphor I'm going with there. I think this will become a useful perspective. I think it's already a perspective. I don't know where I'm going with that. I agree. Good paper, enjoyed reading it.
Yes. Good. It's good to understand what your models can't do. I think it's
yes. And I mean, I realized this paper was written before it came out. In the defense of the GPT-3 authors, I think that they are, in their paper, pretty realistic. They're like, hey, we're like at chance on these NLI tasks, even though we have the largest model conceived of by, people with millions of dollars to burn on compute. And that a lot of the sort of the overstatement of the abilities of the model has been done not by the authors, and they would not agree. All right. I think we're going to call it here. We're done with the paper. We will come back with a new paper next week, and I will share it on Monday, what the paper will be. It'll probably be whatever the second place winner was in the poll that we did, because all those papers were good. All right. Thanks so much for joining me, Adam.
Thanks for having me again.
So Frugo Fruit 90 says, who's the co-host? This is Dr. Adam Lopez. Are you a streamer? Do you have like a Twitch stream that you want to share? No. He's a research manager at Rasa and NLP Research. Sorry, I feel like I've introduced you 4 times, but people come in and out, so I think it's worthwhile to keep doing. All right, thanks so much for joining, everybody. If you're in the US, have a great Labor Day. There will be no stream tomorrow. I am out of office, so I will see you next Wednesday.